Okay, we're going to do a few things. The first thing I want to be, I try to arrange a schedule for all of you to schedule a particular slot to meet with me. And I realize there's something really hard about communication. I feel that if I don't request all of you, but just some of you will connect me via um, line. Okay, this is my line. Just some of you, what I plan to do, let's try to see if this will work because for the rest of the activity, including final project, I would like to have a more uh, um, real-time communication with all of you. So I plan to create a line group which that I can reach out to everyone very quickly. So I'm requesting just some of you will add me as your connection to line. At the end of the semester, or actually at the end, after we create the line group, you can delete me. Okay, no problem. And then I will add you to the group, and then you will add other students. So eventually by Thursday, we hope that everybody will be in that line group. So I can instantaneously contacting you regarding a lot of stuff. Okay, so I will just leave here for some of you to take a picture and so you can add me. Okay. Okay, that's number one. Number two. Number two is interesting. Let me see. I was looking for news. Let me see. I was looking for news for Meta whistleblower. I don't know if you know, I actually just read it yesterday from BBC that there was a very interesting whistleblower. We don't know whether that's true or not, but it's actually started with Meta. So I'm going to do Meta. 1 second. Where is my? Okay, I killed it, I believe. The meta is going to be all lowercase. META. Okay, so that's our participation keyword for today is meta. Okay, so thank you. Thank you for those who come in. Okay, I'm going to talk about a new topic today. This is probably the most important topic uh, in this lecture. I was not in this lecture, in this semester about object-oriented programming. Let me actually try to pull it out. Okay, I hope you can see it. This is the topic. I'm going to start talk about the topic of inheritance. Inheritance. So we're going to talk about a few things. We're going to first talk about what we call single inheritance. And then we're going to talk about virtual function. So single inheritance, virtual function, and virtual function essentially is C++ way to implement a concept called polymorphism. And then we'll talk about memory layout. You will see that I emphasize a lot on memory. And then we're going to see that how you can see the memory layout about a single inheritance relationship. And then after that, we're going to talk about the concept of multiple inheritance or virtual inheritance. And the reason I put multiple inheritance or virtual inheritance at the end, because this is my belief. All the problems that we need to deal with in object-oriented programming, single inheritance should be good enough. We don't need to use multiple inheritance. And I will argue, in fact, when I talk about, when my style of introducing the concept multiple inheritance is usually try to tell you why you should avoid using multiple inheritance. So sometimes it doesn't mean that there is a feature called multiple inheritance, you should just use it. I mean, there's all the cases I can lecture against of using that, while you can always use single inheritance to deal with that. So sometimes programming, sometimes simple is better, okay? So, okay, let's first talk about what is a single inheritance. So single inheritance is a concept we call is a relationship. Is a relationship. So how do I read is a relationship? In this slide, I have the parent class called box. And then I have a special type of box called carton box. So I have a box and carton box. So when I represent an inheritance relationship, you see there is an arc. I actually pointing toward the top, which is the box. So when I say carton and box, that means carton is a box. Carton is a box. So we can use another example. We can say class is a person. And this class may be a teacher. So you can say a teacher is a person. Okay, this is not always appropriate to use this example, but the concept is that when I have two concepts, I want to represent is a relationship, so I can use this. Class, carton, and class box is a relationship. So this is just conceptually, that's actually what inheritance is trying to deal with. But of course, there is a programming context about how do you represent this concept of inheritance and what kind of things we need to worry about is the situation we want to deal with. Okay, so I'm going to use an example which I put it, sorry, why can I get out of here? Okay, maybe I will use this example to show you a better. So what I did is in an inheritance relationship is usually we have something we call base class, and we have something called derived class. So sometimes I would say base class is a parent class or ancestor class, and derived class is sometimes we call child class or sometimes offspring. Okay, so essentially a derived class is a base class. Okay, so that's, I mean, for example, I can give you a more complete picture. For example, this is what we call an inheritance hierarchy. This is a more complicated picture of a bunch of class, and they are related to each other according to that is a relationship. For example, a teacher is a faculty. A faculty is an employee. An employee is a community member. Or a student is a community member. Okay, so that's, you can see that this is sometimes we call inheritance hierarchy. And this represents how each class of object, they're related to each other according to this is a relationship. By the way, the whole thing you can see is a single inheritance, single inheritance, single inheritance. And this is what we call multiple inheritance. This is what we call multiple inheritance. And the multiple inheritance means that a single derived class has more than one base class. So administrator teacher is an administrator. It is also a teacher. I mean, in my case, I have two roles. I am a faculty member of electrical engineering, but I'm currently also serve as an administrator for our college. That's why I actually have a dual role. So this makes sense sometimes that I actually have, I am an administrator. I am also a teacher. And both administrator and teacher, they are faculty, and so on and so on. Okay, so sometimes naturally you think about multiple inheritance means that you have one derived class have multiple base class. Okay, so this is give you some example. So now I'm going to show you the code to let you know how it works. So by the way, in this lecture, I'm going to use a particular GitHub. Sorry, I have to kill this one. No, why did I'm looking for my Firefox. Okay. So I'm using this one, CPP04, under the GitHub. I will share with you the link. Oh, by the way, the link is on the top. Okay, CPP04. And over here, I want to use an example. So you're familiar with this called GPS.h, right? You're familiar with this already. Let me actually using my window to control this. No, I want to use a different one. Very strange. Where's, oh, here. This is CPP04, HW4 reference. And I believe that you have seen this file before, but I actually did some changes. But the changes is just for understand the memory layout. Okay, for memory layout to understand that how the memory was being arranged in C++, you need to do something different, which is not the focus of this particular lecture. But this part you should be familiar with, that we have the class GPSDD, and then we have private, protected, public, and then we have two attributes, which is a latitude and longitude, and then we have a constructor, we have member function, we have operator overloading. Okay, so we have a bunch of things that you should be familiar with right now. By the way, this will be your homework assignment number 2. I'm actually teaching you such that we actually land ourselves into the next homework assignment. Okay, so this is a GPS location. Okay, so now we're going to try to ask you what kind of inheritance relationships I'm going to do. So one of the things about GPS is that this GPS class only have a 2 attribute, longitude and latitude. I'm not sure you remember this, but during one of the earlier lecture, I said, okay, if I want to implement the service of Google Maps. So in Google Maps, not only I have longitude, latitude, but also I have a label. I have a label saying that, hey, this is a label of National Cheng Kung University, or this is the label of Din Tai Fung, or this is the label of some hotel that we will visit this afternoon. So usually we see that not only we're interested in the latitude and longitude portion about the information about a location, but we're interested in other information. If you go to Google Maps, you actually see there's a lots of information besides just these two coordinates. Therefore, I actually create another class called label GPS. Let's try to take a look at this example, label GPS. So this is already there somewhere in the code, but I'm going to define another code. Let me use Emacs. This is called label GPS. We have a label GPS.cpp and label GPS.h. Let me actually show you. By the way, you see this file, you will see all my instruction notes. So I talk about what kind of things we're going to talk about. But here is the idea of a label GPS. So you see that this is a semantic of a single inheritance. I said I declare a class called label GPS. And now this is the syntax for inheritance. Is this column. So any class name, when you declare with a colon, that means after the colon is the base class. So before the colon is the derived class, and after the colon is the base class. So essentially saying that label GPS is a GPS DD. This is a relationship. So what is the difference between this? You can see that everything else is the same. If you look at this is a constructor. The last line shows here. But inside here, I only have one attribute. Only one attribute is a string. std colon string label. Okay, that's all I have. So essentially, this class called label GPS, I only declare label. Okay, now I want to ask you a question. If I create an object from this class called label GPS, how many attributes does this object has? So assuming I have a label GPS, I actually create an object. How many attributes do I have? The answer is 3. Because I have a one attribute, which is a label I already have. But then I inherit because label GPS is a GPS DD. And inside GPS DD, how many attributes do I have? 2, longitude and latitude. And because I inherit from GPS DD, I also inherit those 2. So therefore, this is a way for me to expand the original definition, expand from the base class, which is the GPS. Now I actually introduce a new attribute called label. And now when you create an object under this derived class, you're going to have you're going to have a 3 attribute, latitude, longitude inherited from GPS. And then I have one more, which is a label. Okay, so this is a simple example for you to see that, okay, so that's why sometimes doing object programming is interesting, is that usually a programming is like you know precisely everything you want to work on, and then you just basically finish in one shot. Object programming, different. Object programming, you started with GPS DD, and after a while, you actually realize, oh, I need this extra attribute called label. And in this case, you don't need to modify GPS DD. You can use this mechanism called inheritance. And then you can just simply declare a new class. And then essentially you can add a new attribute. You're done. Okay, so this is called single inheritance. Okay, any question at this moment? Okay, so we're going to look at the syntax. Okay, this is a concept between label GPS, and then I'm going to show you the general context looks like this. I don't have a, okay, I will use this side. Okay. So you see that you have two classes. One is called base class. One is called derived class. And then syntactically, which I probably should modify. Let me actually modify here, make it simpler. Syntactically, what I really want to do is here, there's a colon and says parent slash base. Okay, syntactically, this should work this way. Okay, so I have parent class, base class, and then I have a child class or derived class. Remember, when I put a colon, after colon, whatever I put here is referring to build up that is a relationship with another class. And syntactically, it looks like this. Okay, so this means that on this side, I actually have a interesting representation about the relationship between these two classes or between two objects that's created based on this inheritance relationship. And now you see that I actually put something private here, protected here, private here. Now we're going to introduce why we need the three keywords called private, protected, and public. Okay, so what is a private? So I'm not going to talk about, let me see, what should I start with? Okay, I will start it with public. So whenever you declare anything is a public, that means any piece of code outside of this class, they will be able to access whatever variable you have. So that's called public. For example, longitude, latitude in the code I show you, they are public. Means that everyone can actually derive to have that. Protected, on the other hand, is that only the derived class can access, not other people. So now you see the difference between public and protected, which means that if I actually put latitude, longitude under protected, that means if I have a code which is not a child and derived class, like a label GPS, then if I try to access to the longitude, latitude, it will be an error. However, if I actually create a child class called label GPS, then I will be able to access directly through the protected. So protected is the key word for us to differentiate certain property about the object being only accessible to the derived class of this class we're talking about. Okay, so now you know the difference between protected and public. Now I want to talk about private. So what is a private? Private means that this particular portion about your code can only access by yourself, not even by your derived class. Okay, so let me summarize. If you're a public, everybody can access. And of course, the derived class can access. That means if you declare anything in public, you will inherit from your base class. If you have something in protected, that means your derived class can not only access, but you can inherit from that as well. And nobody else can do that. But if you put it in the private, that means nobody can access to that and nobody can inherit it from that as well. So if you put something in the private, then you cannot even inherit that property. If you put longitude, latitude inside private in the GPS.h, then even you have a label GPS, you cannot access to that. Okay, so that's the basic idea about, and later I will tell you the other thing is called, you can add another keyword called public, protected, in front of parent and base, which I will not introduce that complexity at this moment. I want to first introduce you the simplest one. That's why you can see that if I have a base class, if I have a variable which is protected, the derived class will be able to cover that. But if you have an attribute which is a private set by the base, then even the derived class will not be able to access to that. Okay? Any question? Okay, let's look at the code and then see what does that mean. Okay, I'm going to have now let's go back. We have a label GPS, public GPS DD with all this. Okay, so let's try to run this program first. I want to check my make file. Let me sure. Yeah, I think I have this. Okay. Okay, I believe I have a program which is everything is compiled. Okay. So I do a test thing person. Okay, I have a bunch of stuff. Let's try to see what the program is doing. Okay, the first portion, you see that I'm actually printing a label GPS. A label GPS, you see that have a label, has a latitude, longitude. Okay, let's actually remember this. Of course, this is a JSON representation. Let's actually take a look at my program, which is star.cpp. I believe I have a program called test thing person.cpp. Let's take a look at this program. So now you see that I actually create an object. Instead of create the object, oh, by the way, before we do anything, you should see that over here, I actually include this new file called label gps.h. So in order for you to use that one, you actually need to include label GPS. However, I don't need to include gps.h. Why? Because inside label gps.h, the first thing you see that is it include GPSI. So if I inherit from a base class, I must already include that base class, the .h file already here. Okay, so because I include GPS.h, I can actually do the inheritance properly. Okay. Okay, let's take a look at this. So I include the label GPS.h, and then now I create an object. So I create an object called GPS home woodland. You see that this is a little bit different from what we used to see. If you take a look at the code we used before, let me go back to the other directory. Now this one, where's my code? That's very strange. Okay, fine. What? No, I'm not looking for here. I'm looking for. Here. Okay. If you remember my code, I will take a look at test if you remember this piece of code, it's very similar, but when I create the object GPS home Woodland, you see that my constructor only has two arguments because GPS object, I only need this two coordinate. But if you compare to what I just showed you earlier, that now I have a constructor taking three arguments instead of two. Why is that? It's very naturally because I declare a new class called label GPS, and I really need to include the third element, which I can configure the extra attribute called label. All right. So that's why when I say GPS home Woodland, I don't know if you know. This is a test for UC Davis student because I actually gave them this two number. I wanted to guess where that was. That was the coordinate exactly for Costco. So Costco is very popular, not just in Taiwan. Okay, it's very popular in the U.S. I mean, a student cannot survive without going to Costco. I mean, we don't have so much good food like what you guys have in Taiwan. So we have to go to Costco to buy lots of food and to survive. And chocolate as well. By the way, the chocolate I gave you, those are from this particular Costco, okay, a while ago. Okay, so we have to give three attribute, but now we're going to look at the mechanism about the constructor. Okay, let's take a look at the constructor. Let's take a look at label GPS. First, let's take a look at the constructor over here. You see that the constructor is essentially double, that's two coordinate, and then I have a string. Okay, I declare the constructor for label GPS. So by the way, when you do inheritance, you still need to define your own constructor. Because when you inherit, you can see that the GPS and the label GPS, their constructor need to be different because their information is different. So I have the three, but I want to show you the implementation. If you take a look at the CPP file, now let's take a look at this. This is a constructor. This is a bit tricky. Let's actually take a look at this. So let's first take a look at the first two lines. The first two lines looks okay. Why? Because I declare constructor. So what is a constructor? The class name, colon, and the class name. So a constructor means the function name is the same as the class name. This is a constructor. So the constructor, as we see in the .h file, it has three attributes: argument latitude, argument longitude, and argument label. Okay, I have the three. So this part is not so hard. You declare a constructor, how it works. But the interesting part is the line below. You see that? Whenever you see a colon, that means derived class and base class. So when you have doing this, a colon, this is what? This is a constructor of your parent or base class. So when you create an object under a inheritance relationship, when you want to do constructor, you actually need two parts. You have the constructor for the derived class, and also you need to involve the constructor for the base class as well, because you really have a two constructor. I'm actually create two portions of object. One is called GPS, which has two attributes. One is called label GPS, has only one attribute. Added together, three attributes. Okay, let me ask you a question. If I have a two constructor, you can see that here is a constructor. This is a constructor saying this label is equal to argument label. Okay, that's constructor. But there's another function called GPSDD, which only have a two argument. This is associated with the constructor of the base class. Okay, I want to tell you the answer. The answer is when you call this constructor, the first thing the program is going to be executed is the parent constructor. So you're going to execute the GPSBD, whatever it is. And then after that finish, you're going to execute this particular construct in a single base and derive. And if you have a multiple inheritance, let me actually, not multiple inheritance, a more complicated case, let me actually bring up my PowerPoint. I want to show you a more complicated case. If you have a complicated inheritance relationship looks like this, then guess what will happen? Is that, okay, I'm not going to do multiple inheritance. I'm going to do single inheritance only. I started from teacher. I want to create a teacher object. So teacher object has a constructor. I'm going to delay that. So I said I need to call faculty's constructor. So when the faculty constructor realize, okay, faculty still have a base. So I will delay the faculty. I will call employees constructor. And the employees constructor realize I cannot call that right now because I still have a base class called community member. So now you actually from teacher constructor, faculty constructor, employee constructor, now you go to community member, you realize community member doesn't have any derived class, doesn't have any base class. So it means that this is on the root of the whole inheritance hierarchy. Now I can run the constructor of the community member. After I finish, I'm going to ask you employees constructor. And then I'm going to run the faculty constructor. And then finally, I run the teacher constructor. Okay, so when you do inheritance, it's not just about the attribute or property you inherited from above, but also about when you construct an object, when you create an object, you actually know it actually involves multiple constructors. And the order of the execution about the constructor is from the root all the way down to the lowest level in the derived hierarchy. Okay, does that make sense? Okay. Just to clarify that, now I can go back. Okay, so now you know why this particular code is written this way. So when you put together a constructor for derived class, you have to figure out this line. You have to figure out which constructor in the base class I should call, because the base class has actually multiple constructors. So you have to decide whether this is the right constructor. So it's choice about the programmer, but you need to have something. If you don't have this, it will be default constructor being called. Okay, if you forgot this line, guess what will happen? It will be default constructor. Default constructor, there's no argument. So your object, the latitude and longitude value have not been set properly. Okay, so that's the issue. Okay. So now let's go back to the code. So the same way, sorry. Why suddenly it didn't work? Okay, it's fine. I just read some. Thank you. Thank you, Wei San. Okay, so the same way, okay, whenever you left, it does it. The microphone saw my TA is coming. So I will just speak louder. That's okay. Thank you. Yeah, I think that one needs a battery. Okay, so the same way I create another two object from label GPS, and essentially I have two different label, and then I basically create a bunch of other things as well. Okay, so let's take a look at the other way. Okay, this line is interesting. This line is interesting. It says person Felix, and the constructor has a string represent my social security number, my name, and where I live. Okay, where I live. Okay, let's take a look at the person. So I declare another class called class person. And inside the class person, you see that I have 3 arguments. So I want to decide somebody's name, somebody's social security number, and also somebody's home address, the where you live in this particular case. Okay. So I have that method, but now I want to go back to the code. Over here, I create a person. But what is GPS? Can somebody tell me what's the class for GPS home Woodland? The GPS or label GPS? It's labeled GPS. But what should be the constructor expecting for the third argument? Is a GPS, right? So that's why now you have a type mismatching, because GPS home Woodland is a labeled GPS, but my constructor or person is in fact GPS DD. So now you see what I did here. I did something in front of GPS home Woodland. This is called GPS DD reference to a GPS object. So this one, in a technical term, this is called casting. What is a casting? The casting is I change the data type of a variable or an object that I convert that to a different type. So after I've done this, essentially the whole thing being understood together is that now I treat the object GPS home Woodland as a GPS DD. So essentially, I'm treating a derived class as a base class, and such that I actually be able to call this way. Okay, this is called casting. Okay, any question at this moment? You understand what I'm doing? I'm actually casting because of the class, but I believe in inheritance. I don't have to do the casting. Let me do this way. I kind of forget why I put it this way. Let me do this. I believe this way is is also okay. The worst I can get is a warning, but I don't think it should give me even a warning. Okay, let's take a look at the difference. The difference between the 2 lines I just modified is I removed the casting. Okay, casting is a very, very interesting topic, but right now I'm going to gradually introduce you to the beautiful world or beautiful complexity challenge about casting. But let's actually start with a simple case. Let me try to make it again. Okay, there's no complaint. You see that? It's actually when I compile it, test thing person, I remove that. It doesn't matter. Okay, so what happened in this case is that even though my constructor for another object about person, which is the person Felix, even though my third argument, the type, is not exactly match. It is a what? It is a label GPS, but I want to use it as a GPS. So that's the third property I want to tell you about inheritance, that inheritance, that they will automatically treat this as is a relationship. So whenever I say GPS home Woodland, it is a labeled GPS, but the compiler, when they look at this code, they realize I'm expecting the third one to be a GPS. But now you're giving me a labeled GPS. So as long as I can found a relationship, one is a relationship or is a chain, multiple is a relationship such that I can relate this object to the data type I care about. I'm actually checking. Then the compiler will automatically convert the GPS homeland to a GPS object to call the constructor, which makes sense, right? Okay, so let me summarize three things I talk about inheritance. This is a basic. If you understand these three things, I think you can start writing inheritance program. The first thing is how do you declare the base and the derived class relationship such that you inherit all the property from your base class, such as your longitude, latitude inherit from your base class. The second thing we talk about is constructor. So when you create an object from the derived class, you need to worry about how do you, in a chain reaction, to call the constructor of your base class. Because in that sense, when you create a label GPS, you have to connect to the constructor for the GPS class as well. And the third one you should learn is that the is a relationship is providing information to the compiler and such that compiler will automatically convert your derived class to the appropriate class that's actually matching the function signature of another context. In this case, is match the context of the constructor of the other object. Okay, so those are the three things we talk about. By the way, I will, if you go to the CPP04, you actually see a lot of notes I provide. I just want to tell you what is my instruction plan about inheritance. I put under label GPS.h. This is my plan about instructions. So today I talk about is a relationships among class, and I talk about the GPS as a parent class, label GPS as a derived class. And then I talk about single inheritance. I talk about constructor. I talk about casting, and I haven't talked about virtual function or overloading. Okay, but we will talk about that later. But I just want to tell you there is for those of you who are familiar with other programming language such as C++, such as you're learning C++, right? But some of you have done Java. Some of you have done Python in terms of inheritance. But I want to tell you, this is ugly part about programming, okay? So the single inheritance in C++ is the same as single inheritance in Java, single inheritance in Python. But multiple inheritance is in C++, there's nothing similar. Meaning that in Java, by the way, Java doesn't have a multiple inheritance. So Java is a better language. Java doesn't have a multiple inheritance, period. But Python has a multiple inheritance, but Python's multiple inheritance is different from multiple inheritance. And C++ has another concept called virtual inheritance. Later, I will tell you what's the difference between multiple inheritance and virtual inheritance. And Python's multiple inheritance is the same as the virtual inheritance in C++. And because of this relationship, sometimes if you're familiar with programming, particularly in Python, if you're a Python programmer familiar with multiple inheritance, be careful that in C++ the concepts are different. Okay, so I'm going to stop here. We're going to talk about this on Thursday. I will create a line group once I start having some of you connect me. Okay, all right. See you on Thursday.